Hello everyone. In this video, we shall discuss how to solve systems involving quadratic equations. For our first example, we have the system x plus 3 equals to y, which is linear in both x and y. It is linear because the degree of the equation is 1. It's linear in x and linear in y. And the second equation is y squared plus 2xy equals negative 1. And this equation is quadratic in the variable y. So for the solution of this problem, since the system has one linear and one quadratic, then we need to solve for x or y from the linear equation. So in this case, from the first equation. But since equation number 2 is quadratic in y, it will be simpler if we're going to solve for the variable x coming from equation number 1. So from 1, which is x plus 3 equals 2y, we are going to solve for the variable x, and this will give us x is equal to 2y minus 3. Now let's call this equation the star equation. So from the star equation, we're going to substitute it into equation number 2, or into the quadratic equation. So we have y squared plus 2xy equals negative 1. So for the variable x, we're going to replace this by 2y minus 3. So we get y squared plus 2 times 2y minus 3 times y equals negative 1. So using algebraic manipulations, we have y squared, and then 2 and y will be distributed to both 2y and negative 3. So that will give us plus 4y squared minus 6y. And then the negative 1 at the right side will be transposed to the left side. So that becomes positive 1. And then the equation now is equal to 0. So this is now quadratic in the variable y. And combining like terms, we get 5y squared minus 6 times y plus 1 equals 0. So factoring this equation, or factoring the quadratic expression, we get 5y minus 1 times y minus 1. So solving for y, no, we're equating both factors to 0. So we get 5y minus 1 equals 0 and y minus 1 equals 0. For the first equation, we get y is equal to 1/5. And for the second equation, we get y is equal to 1. Now, since the first equation yields y equals 1/5, we are going to substitute this into the star equation. So in the star equation, we have x is equal to 2y minus 3. So substituting 1/5, we will get 2 times 1/5 minus 3, which is equal to 2 over 5 minus 3. And eventually, this will be simplified into negative 13 over 5. And then for the second equation here, we got y equals 1, and then substituting y equals 1 to the star equation, we get x is equal to 2y minus 3, which is x equals 2 times 1 minus 3, which is x equals 2 minus 3, and it is simplified as negative 1. So therefore, our solution set would be the set of ordered pairs x equals negative 13 over 5, comma, y equals 1/5. And the second ordered pair would be x equals negative 1 and y is equal to 1. Now, for the second problem, again, we have another system having one linear and one quadratic equation. So again, we're going to solve for either x or y from equation number 1, but observe that in equation number 2, it is quadratic in the variable x, so it will be simpler if we're going to solve for the variable y from the first equation. So from 1 again, we have 3x minus 4y equals 7. So we're going to solve for the variable y. So we will transpose 3x. So we get negative 4y equals negative 3x plus 7. And then dividing both sides of this equation by negative 4, this will yield y is equal to 3x minus 7 over 4. So observe that I changed the signs of the terms in the numerator because of the division by negative 1. And then we call this the star equation. So the star equation will now be substituted into equation number 2. So in equation 2, so substituting to equation number 2, we get x squared minus 4x minus 3. And then since this is the variable y, that should be replaced by 3x minus 7 over 4. And then we have plus 1 equals 0. Now, since there's a denominator 4, we can multiply both sides of this equation by 4 to remove the denominator. So we get 4x squared minus 16x. And then 4 times this thing would mean that 4 will be cancelled out. So that means negative 3 here will be distributed to 3x minus 7. So that will be negative 9x plus 21. And then we have plus 1 equals 0. Now, adding like terms here, we get 4x squared, and then negative 16x minus 9x is negative 25x, and then 21 plus 1 is, I'm sorry, this should be 4. Okay, sorry for the error. So this should be 4. So 21 plus 4 is plus 25 equals 0. Okay, so factoring this quadratic expression, we will be getting 4x minus 5 times x minus 5 equals 0. So equating both factors to 0, we have 4x minus 5 equals 0 and x minus 5 is equal to 0. So for the first equation, x is equal to 5 over 4. So if we're going to substitute this value into star, we get y is equal to 3 times 5 over 4 minus 7 all over 4. And this will give us y is equal to 15 over 4 minus 7 all over 4, which will become 15 over 4 minus 7 is 15 minus 28 over 4, which is negative 13 over 4. And then since there's a division by 4 here, we multiply this by the reciprocal of 4, which is 1/4. So that gives us negative 13 over 16. So therefore, for this particular equation, the solution set would be the ordered pair x equals 5 over 4, comma negative 13 over 16. And then for the second equation, since x minus 5 equals 0, that means x is equal to positive 5. And then substituting this to star, then we have y is equal to 3 times 5 minus 7, which is over 4, which is y is equal to 15 minus 7 over 4, which will be simplified into 8 over 4, which is equal to 2. So that means the second ordered pair would be x equals 5 and y is equal to 2. So this will be our solution set. Now for our third example, again, this is a system having a linear equation and a quadratic equation. Now observe that the quadratic equation is quadratic in both x and y. So it doesn't matter if we solve for either x or y from the linear equation. However, here, we can actually solve for y for simpler expressions. So from the first equation, we will be solving for y. So that means we will transpose negative y to the right side and transpose 4 to the left side. So that gives us 2x minus 4 is equal to positive y. And then substituting this to equation number 2, we will be getting x squared plus a y squared will be 2x minus 4 quantity squared equals 13. And then we will be expanding this to x minus 4. So that will give us 2x quantity squared, which is 4x squared. And then this will be minus twice the product of the following, which will be 16x. And then the square of negative 4 is positive 16. And then again, we have equals 13. And then writing this equation in the standard form, we will be having 5x squared minus 16 and then plus 3 equals 0. So this is now a quadratic equation in the variable x. So factoring this quadratic equation will give us, okay, 5x minus 1 times x minus 3. So therefore, 5x minus 1 is equal to 0, which will be x is equal to 1 over 5. And then we substitute this to the star equation. So we have y is equal to 2 times 1/5 minus 4. And simplifying, we have 2 over 5 minus 4, which is equal to negative 18 over 5. And then for the other factor earlier, so x minus 3 equals 0, we solve for x, that's x equals 3. And then substituting to star, we have y is equal to 2 times 3 minus 4, which is 6 minus 4, and it's equal to positive 2. So our solution set would be the ordered pair x equals 1/5, comma, y equals negative 18 over 5. And the second ordered pair, we have x equals 3, comma, y equals 3. So this is our solution set. Okay, now for the fourth equation, or fourth system, observe now that our equations in this system are both quadratic. So they are both quadratic and they are of the same form. They actually follow ax squared plus by squared equals a constant. So which means to solve for x and y here, we will be using the elimination method. So we can eliminate either x squared or y squared. So to eliminate x squared, we will be multiplying the second equation by negative 5. So that will give us 5x squared plus 2y squared equals 22. So this is the first equation. And then the second equation will become negative 5x squared plus 15y squared is equal to negative 5. And then adding the resulting equations would give us 17y squared for the left side. It's because 5x squared will cancel out with negative 5x squared. And then the right side will be 22 minus 5, which is 17. And then dividing both sides by 17, we get y squared is equal to 1. Now, using the square root property, the values of y that satisfy this equation would be positive and negative 1. So now, if y is equal to 1, then we have to solve for x using any of the two equations. Okay, so let's use equation number 2. So x squared minus 3y squared equals 1. So substituting y equals 1, we will be getting x squared minus 3 times 1 squared equals 1. And this will give us x squared minus 3 equals 1. Transposing negative 3 to the other side, we get x squared is equal to positive 4. And then again, by the square root property, x is equal to positive negative 2. So this means that from this part of the solution, the ordered pairs or the points that will satisfy the given system would be x equals positive 2, comma y equals 1. And then also we have x equals negative 2, and then y is equal to positive 1. Now for the other y value, if y is equal to negative 1, actually we're getting with the same, we're using the same solution. So we will be having x squared minus 3 times negative 1 quantity squared equals 1. But negative 1 quantity squared is positive 1 multiplied to 3 will still be 3. So which means we also have x squared minus 3 equals 1. So transposing negative 2 to the other side, we get x squared equals 4. And by the square root property, that gives us x is equal to plus minus 2. So additional um, solution would be x equals positive 2, y equals negative 1, and x equals negative 2, y is equal to negative 1. So our solution set has four ordered pairs. And then finally, for our last system, we have a system containing both quadratic equations. And if you observe that the form of these quadratic equations are or is ax squared plus bxy plus cy squared equals a constant, and one of the constants is 0. So when one of the constants is 0, we will be trying to factor, or we will be factoring that equation. So from 2, we have x squared minus 4xy plus 4y squared equals 0. So when we factor these, we get x minus 2y times x minus 2y equals 0. So this will actually imply that x minus 2y is equal to 0 because the factors are the same. And this would mean that x is equal to 2 times y. So from this, we call this the star. So this star equation will be substituted to equation number 1. So equation 1 is the x squared minus 3 times x times y plus y squared equals 7. So every occurrence of x will be replaced by 2y. So we get 3 times the quantity of 2y squared minus 3 times 2y times y plus y squared equals 7. So simplifying further, 2y quantity squared is 4y squared times 3 is 12y squared. And then we have 3 times 2y times y is negative 6y squared. And then we have plus y squared equals 7. So adding like terms in the left side, we have 7y squared equals 7. And this would imply that y squared is equal to 1. And by the square root property, y is equal to plus minus 1. So now, using both of those values, so if y is equal to positive 1, then the star equation, we get x is equal to 2 times 1, which is 2. And then if y is equal to negative 1, then the star equation will be x is equal to 2 times negative 1, which is negative 2. So our solution set will be the points x equals 2 and y equals 1. And then the other one is x equals negative 2 and y is equal to negative 1. So this ends our discussion of the solution of systems involving quadratic equations. So I hope that you learned something, and please do not forget to subscribe to my channel. Thank you.